So we will make today's lesson as easy as we possibly can. We are starting to talk about quadratic functions. So, you talked about this in Algebra 1, but you didn't really go into a lot of detail. That's what Algebra 2 is for. But you're all really excited about that. Okay, so a quadratic function is a function, nobody should be talking, function that is defined by y equals ax squared plus bx plus c, where in this equation, a, b, and c have to be real numbers, and a cannot equal 0. If a equaled 0, then 0 times x squared is 0, and then we would have an x in there, so we would have a linear equation, which is not a quadratic equation, linear function or quadratic, or linear function or linear equation. Okay, so the shape of a quadratic function is a parabola, which we're going to talk about in the next one. You guys want to try doing music while we do notes? We did that last period. It was kind of interesting.
No.
No.
That's hard.
No? Too distracting? Okay. Okay, so a parabola. Move this up. A parabola is a big U, either upside down or upright. So let's go through some terminology here. The point where the parabola either bottoms out or tops out, anybody remember what that's called? What? Okay, so that's a vertex. So the vertex is either the very lowest point or the very highest point. Would you all agree that in this first one, that is the lowest point of the graph, or the minimum? And in this one, it's the very highest point of the graph, or the maximum. So anytime you are asked to find the minimum or maximum, you're asked to find the vertex. They might just say find the maximum or the minimum, but based on what we see here, that's the vertex. Okay, now, we also have a line that goes directly through the vertex in both of these. Does anybody remember what that's called? Lydia. Something like that. Think back to geometry. This is where, if you take the right half of this parabola and fold it over onto the left half, it should fit exactly. Marcy? Good, the axis of symmetry. So the axis or line of symmetry. So you studied that in geometry. We're back to see it again. I know that excites all of you. Okay, so that's about the extent of it as far as today. We're going to get into this in a lot more depth, but we're just doing a general introduction today, which involves graphing. Yay. All right, but it's the easy, kind of tedious, but easy kind of graphing. All right, make a table of values for integral values of x where -5 is less than or equal to x is less than or equal to 5, and use the table to graph the function. Let me read that one more time in case you can't read it up there. Make a table of values for integral values of x, comma, -5 is less than x is less than or equal to 5. And then use the table to graph the function. The function that we're graphing here is y equals x squared minus 1. Okay, so here's how we're going to go about this. When it says integral values of x where -5 is less than or equal to x is less than or equal to 5, all that means is, we're going to set up a table here. We're going to plug in the values -5 all the way up to +5. -5, -4, -3, -2, -1, 0, 2, 3, 4, 5, all the way down. What are we plugging those into? What do we think? We're plugging them in for x into this function. So y equals x squared minus 1. Leave some room there, and then let's put the actual xy coordinates in the last column. Okay, so in the very first one, let's do lots of extra credit here. We have quite a few numbers to plug in. In the first one, what are we plugging in for x into this function? Stacy? -5. So -5 squared is what? And 25 minus 1 is? 24. Everybody give it up for Stacy. So the first coordinate is -5, 24. Okay, somebody do the next one for me. Chaz. -4. -4 squared is? And 16 minus 1 is? 15. So the coordinate is? -4, 15. Cool, everybody give it up for Chaz. All right, next one. Next one, let's see. Ashley, G.
-3.
-3 squared is?
9.
And 9 minus 1 is? So the coordinate is?
-3.
Good, everybody give it up for Ashley. All right, next one. Next one, let's see. Josephine.
-2
Uh-huh.
squared minus 1, and that's 4 minus 1, which is 3.
Good, so the coordinate is?
-2, 3.
Good, everybody give it up for Josephine. Next one, let's see. Rachel?
-1 times 1 minus 1 equals 0.
Good, coordinate?
-1, 0.
Good, everybody give it up for Rachel. All right, next one. Marcy?
So 0.
Yep.
Minus 1.
Good.
So it's -1.
Coordinate?
0.
Good, everybody give it up for Marcy. Okay, next. Lydia? 0, so the coordinate is? Good, everybody give it up for Lydia. Anybody starting to see a pattern here yet? It's going backwards. So if we plug in 2, we get 4 minus 1 is 3, so 2, 3. Anybody think they can tell me the next 3 coordinates without actually doing the math to them? Except that I messed that up. Nope, I didn't mess that up. Okay. Let's see. Riley? Good? Good? 4, 15, and then the last one is 5, 24. Okay, how did she get somebody? Ever give it up for Riley? How did she get that? There's a specific thing that she was looking at, I think, to get those numbers. Let's see. Lydia, go ahead.
Because on the other side of a line of symmetry is the opposite of positive.
Okay, as far as the x values, true, good. Okay, everybody give it up for Lydia. Marcy? Oh, what?
So only the x values change because moving back to the y is the same.
Okay, oh right, good, okay, good. So the y's, it's they're symmetrical. So 24s match, the 15s match, the 8s match, the 3s, and they all turn around right at 0. Okay, so now it says to actually graph this. All right, so let's draw a graph. We know we have to get up to 24 on the y-axis. And you can make your scales different. It doesn't really make a difference if your scale for the x-axis is a little bit different than the y. X, y. So since we're only going to up and down to 5, we can go by ones. 4, 5. 1, 2, 3, 4, 5. So this is where it becomes really important to label these. 2, 3, -4, -5. Okay, and then since we have to get all the way up to 24 on the y-axis, anybody have a good scale for us that would work? 2s. Okay, good. 2s would work. 2, 4, 6, 8, 10, 12, 14. Okay. So this is where, again, make sure you label 14, 16 so that anyone who's looking at your paper can see what exactly you're doing. Okay. All right, so somebody tell me how I get to my first coordinate, which is at -5, +24. Easy extra credit points here. Ashley R?
You start in center at 0, 0.
Uh-huh.
Go to left 5
Uh-huh.
and up.
Good. Everybody give it up for Ashley. Next, Kendra. Good. 15, which is halfway between the 14s and the 16s. Everybody give it up for Kendra. Next, -3, 8. Somebody point me in the right direction for that one. You want me to just do them? Okay, Orlando, go ahead.
-3.
Uh-huh.
Go back 3 and then up 8.
Good. Everybody give it up for Orlando. Okay, then we have -2, 3, -1, 0, 0, -1, which I did not put on here. It's okay. Then 1, 0, and it should be a mirror image of the other side. So like that. And then you want to connect these with the best curve you possibly can. So we don't really have tools in Algebra 2 to draw a perfect parabola, so you just have to really draw it as best you can. Okay, questions? Okay, pretty easy, right? Okay, next, graph the given quadratic functions on the same set of coordinate axes and then compare the graphs by indicating a bunch of information. All right, there are tricks, by the way, to graphing these that we'll go through over the next several days, but you want to see where those tricks come from first, which is why we're doing it this the long way first. Okay, so for each of these functions, y equals 2x squared, y equals 2x squared minus 8x plus 8, and then the last one, we have to make 3 separate tables. And then fill in those tables. So, let's see. Let's start with y equals 2x squared. Oops. This is the x column. Y equals 2x squared, and then the coordinate, x comma y. So for the first one, let's start by trying out -2, -1, 0, 1, 2. You don't have to use -5 to +5 all the time. Okay, so you want me to just run through this really fast? Yeah? Okay. So we get 2 times -2 squared. -2 squared is 4. 4 times 2 is 8. So the first coordinate is -2, 8. Then we go 2 times -1 squared, which is 2. So -1, 2. 2 times 0 squared, 0. So 0, 0. And then this is where it turns around again. So 1, 2, and 2, 8. All right, so that's the first one. Whoops. That's the first one. Then we have a table for the second one. Y equals 2x squared minus 8x plus 8. You guys want to see the math on this, or are you okay with me just putting up coordinates? What? One of these and then just give you the rest of the coordinates? Yeah. Yeah, Stacy? Yeah. Okay, oh, but yeah, good point. So with these, you typically want to have, if you're doing the plugging it in way, you want to have 5 coordinates. So I like to start at -2 and go to +2, but you want to have, yeah, at least 5 points and try to start with ones that are symmetrical about the y-axis. Other questions? Yeah. Do we, what? Yes, you can. You can get one that is not symmetrical on the y-axis. Yes, and that's actually going to happen in the next couple of these. Okay, so -2, -1, 0. Start with these points. Okay, so 2 times -2 squared minus 8 times -2 plus 8. Okay, so we're going to do this in our heads. -2 squared is 4. 4 times 2 is 8. 8 plus 16 is 24, and 24 plus 8 is 32. So this first coordinate is -2, 32. Marcy, do you have a question? Go ahead.
So when we're doing our homework, they're going to give us questions like that. Does it matter what number we start on?
I would say no, it does not, but I would say start with these because they tend to be symmetrical about the y-axis. Or if they're not about the y-axis, they're very close to that. And you'll see in here how that works. Okay, so the next one we have is when you plug it in, you get -1, 18, then 0, 8, 1, 2, and 2, 0. So this is where you guys can see so far we don't have any symmetry happening. The way you can tell that it becomes symmetrical is right in, like in this one, it started to turn around and you got the same number. So this is where you would add another number at the end. And if you add another number on this one, you get 2 again. So this is where you can start seeing, do you guys see that symmetry? So you can, what? You can keep, you can keep going if you want, but you should be able to see that the next one, 4 would match up with 8, and 5 would match up with 18. So you don't have to keep doing the math, but once you see it turn around, then you can. Does that make sense? Okay. All right, then the last one. The last one is y equals 2x squared minus 8x plus 10. Do you want me to do one of these, or can I just give you the coordinates? Just give you coordinates? Okay. All right, so this one you have negative 234. Oops, yes, thank you. Okay, so negative 234, negative 120, 0, 10, 1, 4. That's still okay. 2, 2, 3, 4. And that's, again, you can start seeing the symmetry with the y, so you can say 4, 10, and 5, 20, and so on. Okay? Now, as far as graphing it, it says, use these to graph them on the same coordinate system. So let's draw a big coordinate system here to go with all of our wonderful coordinates. All right. Okay, so let's do some color coding here. I'm going to keep my coordinates somewhat visible. The first one, y equals 2x squared, we're just literally putting these on here. You don't have to, if you don't want to go up all the way to like the 34 level, you don't have to, or you can make the scale by 2's again. Let's do that. 234, so 34, 32, 30, and so on. And this one, so that it's spread out a little bit, I'm going to go by 2's. So 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so like I said, we're going to learn some tricks for this so it doesn't have to be as tedious in the future, but obviously we're not there yet. Okay, here we go. Negative 2, 8. So negative 2, 2, 4, 6, 8. Negative 1, 2, 0, 0, 1, 2, 2, 8. So that's the first one. So this one is y equals 2x squared. Then the next one, let's use orange. So we have negative 232, which is way up here. Then we have negative 118. 2, 4, 6, 18. Then we have 0, 8. Then 1, 2, right here. 2, 0. 3, 2. 4, 8. And it's again symmetrical from that point on. We don't have to keep adding points there. So this one is y equals 2x squared minus 8x plus 8. Okay, and then the last one, let's do, I'm not sure if you're going to be able to see this, but we'll try. Okay, so we have negative 234. So negative 234, negative 120, 0, 10. So the points are all just 2 above the other one. Like that. Ooh. Okay, so this blue one is y equals 2x squared minus 8x plus 10. Okay, so it's saying to make sure you go back and look at the directions and do whatever they're asking you to do. We just graphed them on the same set of coordinate axes, and then it says compare the graphs by indicating the axis of symmetry and vertex of each parabola. Okay, so let's start with y equals 2x squared. So for y equals 2x squared, that's this one, what is that point where the vertex is? What's the coordinate there? 0, 0. So the vertex of this is 0, 0. The axis of symmetry is a line going through the vertex. So what is that line equal to? You can call it the, yeah, good. You can call it the y-axis. That's one way of saying it. Or you can just say x equals 0. They both mean the same thing. Okay, next. We do the same thing for The orange one. The orange one, somebody tell me what the vertex is of the orange one. 2, 0. Good. Thank you, Akashni. And the axis of symmetry, if it goes right through here, what is that axis of symmetry? Good. X equals 2. Okay, and then we want to do the same thing for the last one. So for this dark blue one, the vertex of the dark blue one is what? If they go by 2's here. 2, 2. And the axis of symmetry is x equals 2 again. So that's our comparison, and then the last part of the direction says, tell whether the parabolas are the same size and shape. So are they?
No.
They're not the same size and shape? So, in other words, if you were to shift any of these directly on top of each other, they wouldn't fit on each other? They might be in different locations, but are they the same size and shape?
Yeah.
Yes. Yes, they are the same size and shape. They're just shifted around a little bit.
Oh. Yeah.
Questions?
Is this the last example?
No.
Oh my god.
They all want to die. That was really long. It actually felt really long for me, too. Okay, but you're in luck. These last ones are really, really short. This is the longest lesson ever. You should have been in regular Algebra 2 yesterday. Theirs was like 40 minutes. Where are we? 21. Oh, we might get there. Okay, here we go. Last two problems. These are really fast. The equation of a parabola and a point through which the parabola passes are given for each equation. Find the value of the specified point. Okay, y equals 2x squared plus 3x plus c. It's saying that this parabola and this point are on top of each other. They go through each other. So we want to find where c is. Does anybody have a suggestion about how we might be able to do that?
Midpoint.
Not quite the midpoint. How many people would agree that we have an x-coordinate here and a y-coordinate?
I agree.
Do we have x's and y's that we can replace in this equation? Okay, so let's do that. So the y is 0 and the x is 1. So we're just going through and solving this for c. So 0 equals, this is 2 plus 3 plus c. Subtract 5, subtract 5. I'm trying to go fast for you guys so that I put you out of your misery. Okay, questions on that? That's all for that problem. We have one more. Yay, aren't you excited about that? You guys can look at it, and if the first one makes sense, we don't have to go through the last one. Although, I kind of want to see your reactions if we do one more.
Yeah.
See if I can really, really make you guys have a lot of fun today.
It's Tuesday.
It's Tuesday, that's true.
He says that for
Oh! No wonder it's so quiet. Where's Underhill?
know.
Okay. Do we want to go through the last one? You guys tell me.
Yeah.
Yes? Okay, last one. So, you are welcome to move on to your homework if you like, those of you who are dying softly here. Okay, 8 equals -1 squared plus b times -1 plus 3, so we're just going through and solving this for b. 8 equals 1 minus b plus 3. So then when we combine these two, we get 8 equals 4 minus b. And then subtract 4, subtract 4. Negative b equals 4, and then the last step, divide by -1. b equals -4. Questions? We're not done yet. We still have 5 examples left. Darn. Just trying to get you guys. Okay, let's go ahead and it's homework 48, page 288. Go ahead and write that down, and then you guys, you're free.